Hello Physical Science, this is Mr. B, and we are continuing on with Chapter 4 today, and I think we should finish up Chapter 4 in this video, talking about more about the modern atomic theory, and it's how its main focus is on electrons, because they're kind of the hardest one to predict, because they're so small, they're so far spaced out from the nucleus, that they've kind of been the one that have taken the longest to actually get a grasp on of kind of how they move and where they're actually at. We talked about how there's different energy levels last time, about how electrons can jump back and forth between those energy levels based off if energy is added or if energy is taken away from the atom. So now we're going to talk about even more improvements that have been made on how we understand where electrons are located and how they move. So today we're going to talk about the model that scientists use to describe how electrons behave in atoms. So we're talking about the one that's used today, and that's known as the electron cloud. And it is a visual model of the most likely locations for electrons in an atom. So I'd make sure I wrote all of this down. The most important thing that you would need to know for the quiz tomorrow, the most likely locations for an electrons in an atom. That is a big deal because we're going to find out that it's going to be really hard to predict in exactly where an electron is at any point in time. So the electron cloud is a visual model that gives us the most likely locations where they're most likely to be at a certain period of time, because they're so small, they're moving at such high speeds that there's no way we can really tell exactly where they're located. And scientists use the electron cloud model to describe, again, the possible locations of electrons around the nucleus, because like you said, we have not really found a good way to know exactly where they're going to be at any point in time, because they're so small, they're so fast moving. And so how this relates to kind of yesterday is because Bohr's model was kind of like this, but it was further improved by scientists as further discoveries were made. So Bohr correctly assigned energy levels to electrons. However, electrons do not move like planets in a solar system. So we talked about yesterday, again, kind of about Bohr's findings, about how he thought, again, that there was just this line, this circular line, that electrons are constantly traveling along. And if you kind of could move up and down, depending on the amount of energy that's added, you could go from one circle to another, but we know that's not really exactly how it works. They don't just have a straight line path that they're constantly on within each energy level. Today, scientists use probability when trying to predict the locations and motions of electrons and atoms. So again, we know now that it's not a perfect circle that it's traveling along, it's not doing a perfect orbit, but again, it's kind of similar. And an electron cloud, for like the third time, is a visual model of the most likely locations for electrons in an atom. So I would say they probably are making a pretty big emphasis to make sure you know what the electron cloud is. And so here's kind of a picture of what electron cloud is to make it make a little more sense. The electron cloud model replaced Bohr's vision of electron moving in predictable paths. So we know now electrons do not move in predictable paths. So I'm probably going to have a question on the quiz saying true or false, electrons move in predictable paths, and you're going to make sure you put false because they do not move in predictable paths. So here's how the electron cloud model is set up. In the middle here is our nucleus, which contains our protons and our neutrons. We have a pretty good relative idea where that is. And the electron cloud is a visual model of the probable locations of the electrons in the atom. And the probability of finding an electron is higher in the denser regions of the cloud. So if you look here, this red cloud represents the possible locations of where an atom could, or I'm sorry, not where an atom could be, where an electron could be at any point in time. And if you look right in this area, this is the more dense, again, it's kind of a darker reddish color. So this is the most likely place to find an atom for this to find an electron for this particular atom. And as we move out, we can see it kind of slowly starts to get fainter. It starts to dissipate more. And if you can see all the way out here on the outer edge, this is very faintly shaded in, so that means the probability that an electron is out there is much smaller than the probability of it being somewhere closer in here. So that's how the electron cloud works. It shows the probability of where an electron could be. And this next slide I think is pretty cool. It's another analogy. That's one good thing that your book does, is they like to give analogies to kind of help things make a little more sense. And this photograph provides an analogy for the electron cloud. So it says, when the blades of a windmill are at rest, you can count the number of blades. When the blades are moving, however, they spin so fast that you only see a blur. So you know that the blades are located somewhere in that blur, But at any specific moment in time, you cannot be exactly sure where each blade is located. Because if you look here, they all kind of just look like one. And it's kind of the same thing with a ceiling fan. They move and move and move, and there just appears one big circle. That's kind of what the electron cloud is. Right here, the center of the windmill, that can be like the nucleus. And then out here is any possible location for the blades, or, and again, if we want to make it the electron cloud, the electrons. So that's how the electron cloud works. It's the probable location of any place that an electron could be. And again, a windmill is a good analogy because, like I said, we can't tell you like, oh yeah, blade number 1 is right here. Now it's right here. Now it's right here. No, we know it's somewhere in this general area at any point in time. And now we're just going to keep focusing on how electrons behave. So now we have something that's known as an orbital. So this is going to be kind of similar to some of the ideas that Bohr had, because he had orbits. So it says an orbital is a region of space around the nucleus where an electron is likely to be found, and the electron cloud represents all the orbitals in an atom. So within this electron cloud, we have something that are known as orbitals that kind of is a more specific location of where an atom could be. And an electron cloud is a good approximation of how electrons behave in their orbitals. And again, just another analogy. So for analogy in the concept of an orbital, imagine a map of your school. It says mark your exact location with a dot every 10 minutes over a period of 1 week. The dots on the map are a model of your orbital. They describe your most likely locations. And the places to visit you most would have the highest concentration of dots, and the places you visit the least would have the lowest concentration of dots. So again, as we go back to this electron cloud model all the way up here, so within each one of these there are different orbitals that can again further describe where electrons will be. Again, the electron cloud is kind of the whole entire amount of electrons, and within even more specifically we have things that are called orbitals, which are more specific. And here is kind of a breakdown of orbitals, so we actually have some pretty good knowledge about them. So the level in which an electron has the least energy is its lowest energy level has only one orbital, and higher energy levels have more than one orbital. So energy level 1, again, that's going to be the closest one to the nucleus, the one with the least amount of energy. There's one orbital there, and there's the maximum number of electrons is 2. There's 4 orbitals when we move up to the second energy level, so that means there's 4 possible paths that electron could be traveling on, and there's going to be 8 electrons within that second energy level, and then there's 9 and 16 moving on up, and then 18 and 32. So there's no reason why you need to memorize this chart, and I think this chart is a little bit confusing maybe at first glance, so we will discuss more about energy levels and orbitals and the maximum number of electrons more in class, but maybe just being familiar with the fact that the higher energy levels have more than one orbital, and just being familiar with those terms in general is probably important. But again, we'll go over that more in depth in class. And then to finish it off, we're going to talk about how electrons are configured, basically where they're located, and what the most stable way an electron can be set up is. So an electron configuration is simply just the arrangement of electrons in the orbitals of an atom. So it's literally just where are the electrons located within the orbitals. And when all of the electrons in the atom have the lowest possible energy, the atom is said to be in its ground state. So a ground state is when all the electrons in an atom are at the lowest possible energy. So they're all they're evenly balanced out, they're not moving around a lot, they're in their lowest energy state, so that's called the ground state. That's basically where an atom wants to be. It wants to be in its ground state, because that's when it's most stable, it's not going to fall apart or anything like that. And the most stable electron configuration is the one in which the electrons are in the orbitals with the lowest possible energies, which is what we just said. And so we're going to give an example of what that actually means. So a lithium atom has 3 electrons. So in the ground state, 2 of the lithium electrons are in the orbital of the first energy level, and the third electron is in an orbital of the second energy level. So if the lithium atom absorbs enough energy, one of the electrons can move to an orbital with a higher energy, so it can go from this first energy level up to the second, And so this configuration is referred to as an excited state, and an excited state is less stable than the ground state. And eventually the electron that was promoted to a higher energy level, it'll lose that energy and the atom returns to the ground state. So basically an atom can have energy added to it. The energy will cause the electron to jump up to a different energy level. That energy level now is what's called an excited state. It's not as stable as the ground state, so something, I don't know, might be more likely for it to fall apart or to react with something else. A lot of different possibilities when it's in the excited state, but eventually that electron will lose the energy and will return to the ground state. And the ground state of a person is when you're on your floor, so when we're all just standing on the floor, we're in our ground state, we're comfortable. And a gymnast on a balance beam is like an atom in an excited state, not very stable. And that's, even if I was up there on that balance beam, I'd be a lot less stable than the gymnast. And when the gymnast dismounts, she'll return to her lower, more stable energy level. So that is it for chapter 4. Let me know if you have any questions.